Hi. Now, before we can move on with all the material we need to cover, I want to make sure that you know all the mathematical terminology in English. So let's do a very quick review. If we see shape looking like this, of course we call it square. Now, if we see shape like this, we call it rectangular. Shape like this, we call triangle. And this triangle has a base over here, and altitude, or simply height, over here. Okay. Now, let's go through all the basic operations. So, first we've got adding. So, if we have A plus B equal to some C, and the outcome of this operation we call sum. Then, we've got subtracting. Subtraction. Addition, I should add the subtraction. So, this is the case where we have A minus B equals to C. The outcome of this operation we call difference. Then, we've got multiplication. So here we have A times B equals to C, and the outcome of this operation is called the product. Then we've got division, and the outcome of so we've got A divided by B is equal to C, where C is called quotient. Although of course, ratio is also an acceptable answer over here. Now, sometimes we need to deal with exponential expressions when we have A to the power of B, where A is called a base, and B is called the exponent. Now, let's summarize something I hope you all know really well from high schools. So how do we interpret different transformation of these exponents? So, for example, A to the power of -1 gives us a reciprocal. So 1 over A. Now, A to the power of -B, we just need to get rid of the minus, and then we get 1 over A to the power of B. Then, if we see something like this, 1 over 2, this means that we've got square root of A. If we've got A to the power of 1 over C, it's simply C root of A. Now, if we've got A to the power B over C, we get that this is A to the power of B, C root. Then, finally, we can have A to the power -B over C. So, I hope we can conclude, we start with 1 over A to the power of B, and, C root. Of course, here we have some special cases with A equal to, A to the power of 1 equal to A let's review a couple of rules on exponents, which I also hope you remember from high school quite well. So if we have a to the power of b, we multiply it by a to the power of c, is the same as a to the power b plus c. Then a to the power of b divided by a to the power of c is the same as a to the power b minus c. Finally, a to the power of b to the power of c is the same as a to the power of c to the power of b, or simply a to the power of b times c. Okay, and finally, a to the power of 0. How much is that? Well, it is 1. But on a condition that a is different than 0. Remember, this is very important. Symbols like that, 0 to the power of 0, or infinity divided by infinity. I know this is very tempting. It looks like 1, but it's not. Or generally, a divided by 0, we call undefined symbols. We basically do not know how much is that. We are usually told that we don't divide by 0. As you will learn, in the future, of course, we can have some guesses, some very educated guesses based on limits. Like we know that dividing by 0 from the right hand side, assuming a is positive, will get us closer to infinity, while from the left hand side will get us closer to negative infinity. This is why it's so problematic. Left hand side and right hand side limits are just different. In this case, I'll actually recommend a video that you can find also in the repetition for mathematics, where Mr. Wu is explaining very nicely how can we actually arrive at how much is it. So I'm not going to tell you. Please watch the video because it's great. I don't want to steal this from him, even though I want to very much because he's done an amazing job. Those symbols we call undefined symbols, and we do not calculate them. We do not follow operations that are requiring from us to do it. Okay. Now, so how do we know that a to the power of 0 is 1? Well, actually in this case, we can prove it. We can prove this quite easily. And the proof goes like this. Look, when we do a proof, we just need to take left-hand side, for example, of this equation, and through some transformations, we should get at the right-hand side of the equation, which is simply 1 in this case. So let's do so. Now, we've got that a to the power of 0 can be written a little bit different. How about a to the power of b minus b? B minus b will be 0, right? Then, knowing that we arrive at this expression, maybe we can use this rule and express it a little bit differently. A to the power of b over a to the power of b. And this is clearly 1, as long, of course, as a is different than 0. Okay, so I think this is like this is the end of the first part of the revision. Now, I would like you to learn about 2 very important operators that we use in economics and econometric statistics very, very often. And the first one is denoted by this symbol. This is a capital Greek letter, sigma, and it denotes sum operator. Look, when we see this symbol, it basically tells us add up all the elements. But exactly which elements? Well, we will add up indexed by I, and this I I appears over here, and we will have some n at the top. And look, so how do we read this? This part tells you from which element I should start adding well, this element at the top is telling you at which element should I stop. So, look, when we are getting over here, as this is a sum operator, is that we should add x1 plus x2 plus x3 and so forth until element xn. Okay, let me show you this with an example. Let's just say that we have some set of elements x such that they're going 3, 5, 1, -2, 0, 2, -1. Okay, and now look, you can imagine that each of them is indexed like here we have I, here I equals to 1, so this is in other words x1, 2, 3, this would be x4, and so forth. So, now let's just say that I want you to calculate this expression. Okay, now, so I need to start with element number 1, which is 3, then add element number 2, which is 5, and I should stop at element number 3, which is 1, which is 9. And look, basically this is it. If you understand this, this is how far you need to go. But, look, remember that in front of the sum symbol, let's just say we have 5 and 7. We can have something added, like for example 2. What should I do now in this case? Look, I should start with element number 5, so 0. But look now, because I have 2 here, each element I need to multiply by 2. So I will have 2 times 0 plus 2 times 2 plus 2 times -1. But of course, look, I can take this out. I can take this 2 out. And look, this actually is showing us that I can take these 2 out of the entire sum symbol. Because look, 0 plus 2 minus 1 is simply this. So here, of course, at the end, I get a number 2. But if I would have this without 2, I would just have 1. And this is actually associated with more general rule that sigma I equals 1 n k times xi, where k is some constant, is the same as k times sigma and look, in the same way we could introduce here, for example, squares. If we would have squares, then what would I have to do? 0 squared, well, it's still 0. Let's write it like this. Then we would have plus 4 and plus -1 to the power of 2 is 1. We would have 5. But of course, there is no rule that allows us to do something just as easily as simplifying this with squares. Okay, then the next operator we are going to do is called product operator. And for this one, we use capital letter sigma. And look, the only difference is that now, instead of adding, we are told to multiply all the elements. Besides that, everything stays the same. This tells you where you should start, where you should finish. Okay, so let's just do one more example over here, and I think we're done. So if I have pi I equal to 2, 3 xi, that would be the same as 5 times 1, which is 5. And of course, we can do the same things with xi here. If I would have pi from I to 1, 7 xi squared, we would be taking 3 squared times 5 squared times 1 squared times -2 squared times 0 squared times 2 squared times -1 squared, which of course is simply 0. Okay, I think that this is enough for us with the basic information. In the next video, we're going to start covering functions. Thank you for your attention.